Hello everyone, my name is Vivian and I'm a part of Girls in Quantum. They provide free educational resources to girls and students worldwide, bridging the gap in the quantum computing field. So if you haven't checked them out already, go to girlsinquantum.com. Check out resources, events like hackathons, their blog, their team. Join us. Anyway, today I'm going to be talking about the single most controversial topic in all of quantum science. If you are a quantum scientist, you probably know I'm about to be talking about the many worlds interpretation. This is gonna get weird. In our macroscopic classical world, things are predictable. If you look at a coin on a table, it's either heads or tails. But in the quantum world, where electrons and protons live, particles refuse to commit. They like to keep their options open. Think of a spinning coin as a representation of a quantum particle. While it's spinning, is it heads or tails? Or kind of a blur of both at the same time? In physics, this state of being multiple things at once is called superposition. The particle acts like a wave of probability spread out across every choice that it can make. So what happens when you slap your hand down on that spinning coin? You force it to choose. It instantly becomes a definitive heads or tails. In quantum physics, anytime we look at a particle or let it interact with the outside world, that's called a measurement. For decades, one of the biggest problems in quantum physics is this so-called measurement problem. How does a blurry wave of multiple possibilities suddenly snap into a concrete reality the second we look at it? The many worlds interpretation of quantum mechanics is the idea that parallel universes actually exist. Okay, they're not just in comic books or Marvel movies, but they are a mathematical truth. For a long time, the standard answer was that the other possibilities just magically vanish into thin air. That's what's called the Copenhagen interpretation, and it's still wildly accepted by scientists today. But in 1957, a physicist named Hugh Everett proposed the many worlds interpretation for his thesis. He looked at the math and said, what if the other possibilities don't vanish? What if nature doesn't actually have to choose? According to many worlds, when you slap your hand down on that coin, the universe splits. That's what's called branching. In this branch of reality, the coin lands on heads and you see heads. But in an equally real, parallel branch of reality, the coin lands on tails, and an alternate version of you sees tails. Every single time a quantum event happens anywhere in the cosmos, the universe branches into an ever-splitting multiverse. All the possible outcomes actually happen. They just happen in different timelines. Hopefully, right now, you have a lot of questions. Mainly being, if the world is splitting apart right now, why don't I feel it? And physicists' main answer for that is called decoherence, which is the idea that the second that a quantum event happens, it's going to interact with light, particles, even body heat, and instantly snap onto one branch of reality, leaving the other ones completely separated. We're never going to be able to talk to the alternate versions of ourselves or interact with any aspects of another universe. Now, as elegant as many worlds may be, it has some major haters. Okay, a lot of physicists feel like inventing an infinite number of unobservable universes to avoid a collapsing wave function is a massive case of theoretical overkill. But in this book, Something Deeply Hidden by Sean Carroll, which is amazing, I will put the link below because it is what got me interested in quantum in the first place. He outlines exactly how the competition is trying to prove many worlds wrong. At the end of the day, the many worlds interpretation is so compelling that a lot of people don't try and fix the math. It is the purest form of interpretation of the Schrodinger's wave function, which describes how particles move in the subatomic realm. So well, experiment after experiment proves that the Schrodinger's wave function exists, and some people say that that in and of itself is proof of many worlds theorem. What do you believe? Are you going to just accept many worlds theorem and move on? Are you going to be like a Copenhagen interpretation people and just say, no need, we already have the tools that it can give us without needing to know what's going on? Do you think that there is a secret theory that no one has discovered yet? Or maybe cubism or GRW theory or pilot wave theory, or even the idea of quantum gravity is pulling your interest more? Honestly, my interpretation is still under interpretation. I have no idea yet what I fully believe, and that is the space where most physicists are, and in my opinion should be. We should not be complacent, and we should all work together to try and understand the subatomic realm as best as we possibly could. So, I'll leave a bunch of links in the description below so you can continue your research. I hope that now, if you didn't know anything about quantum science, then you're excited to get into this field with so many unanswered questions. And in the future, I would love to do some more in-depth videos of the math and so many other cool phenomena that happen in the quantum realm. Remember to check out girlsinquantum.com for more information as well. Thank you.